Okay, this is section 8.8. This is just an extension of Friday's assignment. So sections 8.7 and 8.8 are the same, but I'm going to do some more examples. So more parallel lines, proportional segments. Remember, we're using proportions to solve for missing side lengths. So in example 1, it says find the value of x. If you have parallel lines, you can set it up x plus 1 over x equals 6 over 4. And that's the easiest way because you could just put your equals in between and put your division bars on either side. So you're setting it up just as it looks. So when you solve cross multiply, remember to distribute the 4 to the x plus 1. And then we have 6 times x. So distribute our 4, so we have 4x plus 4 equals 6x. Subtract 4x from both sides. 4 equals 2x. Divide by 2, and x equals 2. And that's all we had to do was find the value of x. On example 2, it gives us some side lengths, so we have to label. So it says if RT equals 10, so that is this whole length, find the values of x and y. Well, if we know RS is 6 and the whole length RT is 10, then y would just be 10 minus 6, which is 4. So y equals 4. For x, we're going to have to set up a proportion. And we can set it up just like we did the last one, but notice this picture is rotated. So we're going to have to set it up these lengths over these lengths. So I'm going to say 4 over 6 equals 2x minus 1 over 9. Now we can cross multiply. Make sure you distribute the 6. So when we distribute, we get 12x minus 6 equals 36. Add 6 to both sides. So 12x equals 42. Divide by 12. And 42 divided by 12 is 3.5. So x equals 3.5. I'll put that up here too. So we got y, we got x, and that's it. On example 3, we got to find x and y again. Now remember, when the triangle looks like this length right here, the 5x minus 2, we have to double this in order to set it equal to 72, the upper length. So we have to take 2 times 5x minus 2 and then set it equal to 72, because it's only half the length of the top segment. So when we distribute, we get 10x minus 4 equals 72. Add 4 to both sides. Equals 76. Divide by 10. And x equals 7.6. We got x. Now we still need to find y. Now y is a little bit easier because notice these congruency marks. That means they're congruent segments. So we can just take our two expressions and set them equal to each other. So we'll take our 2y plus 18 equals 5y minus 3. I'm going to subtract 2y from both sides first. So I get 18 equals 3y minus 3. Then I'm going to add 3 to both sides. So I get 21 equals 3y. Then divide by 3. And y equals 7. So x equals 7.6, y equals 7. Okay, example 4, find the values of x and y. We had one like this on Friday. So we have to set up proportions. So first I'm going to solve for x. So I'm going to take this length here over 2 and set it equal to 24 over 3. So to solve for x, I'm going to use 3 plus x over 2 equals 24 over 3. Cross multiply. Make sure you distribute the 3 to the 3 plus x. So we have 9 plus 3x equals 72. Subtract 9 from both sides. So 3x equals 63. Divide by 3, and x equals 21. So that's for x. Now we need to set up a proportion for y. So I'm going to use different side lengths. So for y, I can use y over 2 equals 3y minus 8 over 3. I don't want to include this middle section because it has an x. So I'm going to take y over 2 equals 3y minus 8 over 3. Cross multiply. Make sure you distribute the 2 to the 3y minus 8. So we get 6y minus 16 equals 3y. Subtract 6y from both sides. We get negative 16 equals negative 3y. Divide by negative 3. And we're going to get a decimal. 16 over 3. The negatives will cancel. So y is about 5.3 repeating. Okay, I have one more example. In this one, it shows how we have congruent lengths over here on the right side of the picture. If those are congruent lengths, then the left side, these are also congruent lengths to each other. So if we're looking for x, we can just take the two expressions and set them equal to each other. So 7 plus x equals 2x minus 6. I'm going to subtract x from both sides. So I get 7 equals x minus 6. Add 6 to both sides. And x equals 13.